Hi, my name is Vivek, and today I'm going to do my second assignment on network architecture and protocols. In this assignment, I'll talk about big data, Internet of Things, and cloud services, and how these services are affecting business, world, daily lives of the people, and how they are promoting the growth of the world as well. So, Internet of Things is the network of physical devices, vehicles, and other items embedded with electronics, software, sensors and network connectivity, which enables these objects to collect and exchange data. So let's say billions of devices are connected today. 100 billions are going to be connected tomorrow to the internet. And as when these devices connected to each other, they'll make an intelligent system of systems. And when these systems share data over cloud, they transform lives, world, and business in countless ways. I'll give you an example. A traffic camera can monitor congestion, accidents, and weather and communicate that status to a gateway that combines data from other cameras, creating an intelligent traffic system. So I've got a operating system installed here on my virtual machine called Instant Contiki 2.7. So Contiki is an operating system for Internet of Things, and it bridges trillions of low cost, low power microcontrollers, including tiny wireless sensors on the internet. So examples of Contiki is street lighting systems, monitoring for smart cities, radiation monitor systems, and alarm systems. The best thing about this Contiki operating system is that it is a multitasking operating system, highly portable, and the requirements of the system is really low. So the minimum requirements for Contiki is 10 kilobytes of RAM and 30 kilobytes of RAM. So as you can see here, the Kuja, the Contiki network simulator, this simulator allows large and small network of Contiki modes to be simulated. So I'll show you a small simulation here in my Kuja. So I'll go onto File. I'll start with New Simulation. So the simulation is actually done in hardware devices, as you know that all these mobile devices are connected to each other. You can operate, you can close, you can turn off the lights with your mobile devices as well. So I'll type the name of my simulation as IoT, and I'll create that simulation. So this is a virtual environment in which I'll show you how a simulation works. Alright, so I've got a network here. So first I'll do some changes in my network here. Right, I'll just enable LEDs. I'll enable positions. I'll enable 10M background grid as well. Okay, so I'll enable IP as well. So you can control all sorts of things from here within the network where the simulation is going to take place. So now I'll go to my modes. I'll add modes, create a new mode type, and I'll click on Sky mode. So here you can see new pop-up window pops up, and so what you're going to do is you're going to click on browse here, and you're going to select the file here. So in my case, as for the examples, I'll select broadcast example.c. I'll open that file, and I'll click on compile. So now the compilation output is going to take a couple of seconds. First, if you do it at first, it takes a couple of minutes. Now I've already done a couple of times, so it's going to take a couple of seconds now. Alright, so the compilation is done now. I'll create the mode. Okay, So you can I'll tell you about a bit of this as well. So you can enter the nodes here. So this is the simulation control. So when the simulation will run here, you can control the speed limit of the simulation, and this is the timeline of the modes. So this is the mode output, like modes, what are they doing, and all that sort of stuff. Now I'll add 8 modes here. The positioning is random, and I'll add modes. So now you will see some modes appearing here in the network. So now, as you can see the modes here, we're going to start the simulation control. Now you can see the speed and the time that the simulation here, and so you can see here the connection was built between these modes. So these are 8 modes, and as you can take the traffic control exam as well in the real life, right? So 8 different cameras making 7 different cameras making the 8 as the default gateway and talking to each other. So these are the IP addresses of the modes here. So that's about Internet of Things. Now we'll talk about what is big data, right? So big data, yeah. The data actually generated in computers these days is growing exponentially. So big data is the next big thing in computing. So what is big data? Data that is big? Of course, that is big data, but that doesn't satisfy the term itself. So I'll give you an example. I'll start with a small example. So let's say we're sending an email and we're attaching a file to that email that has a size more than 100 MBs. So would you be able to attach that that attachment to that email? No, because that data in that respect to email is big data. So I'll tell you that data is actually is categorized on different levels. So at first level, like back in the days, employees they used to enter data in the computers, right? That's the first level. And the second level is now that users are adding data into the computers these days. Example, Facebook. They've got big databases. Now, every day, a lot of thousands of customers are joining Facebook, so that is they're contributing to that data. Now, the third level is the machines that are accumulating data these days. For example, satellites, for example, robots, and a lot of the other machines as well. So these are all examples of big data. So there is so much data that it is overwhelming the computers. To solve that purpose, now big servers are being made to have different types of data. So now different processes are there for different servers to according to different types of data. So this is all parallel combination. So now we have 10 more times of data than we had 3 years ago. 10 more times of business that we had 3 years ago. So there are two components of big data two components of that are used to solve the big data problem, and that is Hadoop and MapReduce. So Hadoop is a platform for all that big data. So it stores, processes, and analyzes data in any format, quantity, and quickly. It's free from rigid schemas, and it performs operations in parallel, as we discussed before, in any language with maximum flexibility. It scales economically on the hardware of the choice of the computer. It can integrate seamlessly databases like cloud, BI, storage, ATL. And MapReduce is just a brief summary on each server that what data that server contains. So if you're searching a file that is across thousands